Okay, so welcome to this live stream as well. So here we are also going to learn one of the important topic, and we can see these are our community members. Okay, so let's start the our challenge today. That's the challenge 9. Can you see my screen?
Yes,
Okay, great. Thank you so much. Okay, till the time we had completed 8 important milestones into our entire Lean Six Sigma program, and we can say we have divided that into 12 parts so that we can accomplish our goal of Lean Six Sigma learning, implementation, as well as certification, right? So till the time we have completed 8 milestones, that means we have completed till the analyze phase, and today it is an important milestone because we are going to discuss about the one of the most critical phase in Lean Six Sigma, that's the improve phase, right? And just for the recap, in last challenge last week we talked about the root cause analysis. In that we have identified how to identify the root cause of any problem, right? In that we also seen that what are the important root cause categories and how to initiate the countermeasure. In that we also seen what are the 6 levels of the countermeasure. So we identify the root cause till the last session. Now, in this session, what we are going to do, we are going to implement that solution, and also we are going to check what is the effectiveness of it, right? So we are going to validate it. So the theme of today's challenge is implement and validate. Is it clear up to this point? Just checking.
yes.
Okay, great. And as we already check the mood and health, now I think Raj has recently joined. Hi, Raj. Welcome.
Hey, good evening.
Yeah, good evening. How are you today?
Good, good. How are you?
Okay, yeah, yeah. We just checked the health and mood. Yes, everybody is great, including me. Thank you for asking.
All right, thanks.
Okay, great. So we are going to learn this entire implementation and validation of the countermeasure into three important parts. The first part, before to start, let's understand how this improve phase is going to be work. What is the approach that we are going to use into the improve phase? So let's understand that in detail. Just look at these sub-steps into the improve phase. The first sub-step you can see is the generate the solution that we already identified into the last session, right? So that is coming from the root cause analysis. Whatever the countermeasure that we have decided, right? So that is nothing but we generated the countermeasure, we generated the solution. Now we need to evaluate it, and then we need to go for the optimization of it, right? Into the second sub-step, we need to evaluate whether that countermeasure is effective or not. If it is effective, then we are going to optimize it so that we can get the best results. And after optimization, we are not going to uh, do the mass implementation, right? Because it's very important to understand what is the risk that is associated with our implementation. So that's why we are going to select the pilot area, small area, and in that area, we are going to execute that solution. We are going to monitor that solution, what is the effectiveness of it, and once everything is fine, then we are going to implement that solution into the entire area, right? So that is the third sub-step: assess risk and pilot solutions. Then implementation is not like that we just take the solution and we execute, but it also includes a lot of steps that we need to follow. So what are those steps that also we are going to learn into the second element of the today's, how we are going to develop the implementation plan. Along with that, we also need to create the validation plan, right? So once we implement that solution, how we are going to validate it, that also we are going to create simultaneously. And after that, we are going to implement the solution, right? So this is the approach that we are going to follow into the improve phase, right? First, generate, evaluate, and select the solution that we had identified into the root cause analysis. Second, we need to optimize that solution. In third step, we need to execute that into this pilot area, and we need to assess what are the risks that are associated with that implementation. If everything is fine, then we are going to create the implementation plan and validation plan. And after that, we are going for the implementation. Okay. Is it clear? What is the approach into the improve phase?
Yeah, it's clear.
Great. Yeah, great. Thank you so much. Great. So after understanding of what is the approach into the improve phase, now let's understand how to implement the countermeasure, right? So this implementation includes both the part implementation into the pilot area as well as implementation into the entire area. Or we can say it's a mass implementation, right? So the implement countermeasure to avoid reoccurrence of the problem and validate it. That's a second element that we are going to learn today. Let's understand that into three sub elements, right? So the implementation of countermeasure, as I said, it's not like we are just going to execute it, but before that we need to optimize it, then we need to execute, and after that we need to validate it. Okay, now let's go into the detail in each of this segment and understand what are the steps or what are the activities that we are going to take into this each of these sub steps. Okay, so for optimization, there are various tools and techniques that we are going to use so that we can identify the settings or values of the variables to deliver optimize or best results, right? Now, what are these tools or techniques we can use? Can you suggest me any one tool or technique that we have learned so far that we can use for the optimization?
Sir, for optimization, DOE
Absolutely.
it's
Yeah, thank you so much, Sarvana. Yeah, this a design of experiment is one of the icons, the advanced tool or technique that we are going to use. I will explain that in very detail along with what are the preparation that we need to do and what are the four sub elements into the design of experiment as well. And we are also going to see one practical example for our production defect reduction project. And in that, I'm going to show you that how we can conduct the design of experiment there, right? Yes. So this is one of the great tool that we need to use, which consists of the full factorial, fractional factorial, factorial plots, and response optimizer. Now, what are these things that I will explain later once we enter into the design of experiment? Okay. Now, so that's the one important tool we are going to use. What is another one? You're very right. Yeah. What's another technique we can use? It is one of the most important part that we learn into the analyze phase. What is that? Optimization. Okay, let me evolve that. It is the regression analysis, right? So we also see the correlation regression analysis. So in regression analysis, also we are going to optimize the settings, right? So we are going to identify what are the important factors and what is the relationship that those factors are having with respect to our response, so that we can also optimize the settings. This regression analysis also consists of the analysis of variance that you are going to see. That also is the part of the design of experiment. So we can say this is the two important tools we are going to learn. In some cases, if you already have the data collected, we can also use the graphical tools for the optimization. Like we can use those tools and we can see whether any particular machine is effective or any particular settings is effective or not, right? If you already have the data. Now, what are these tools we can use? It includes the scatter diagram. If you're having the multiple factors, we can go for the matrix diagram. We can use the box plot, histogram, run chart, control chart, and multivariate chart, right? So we can also use the graphical tools if you already have the data and if you want to optimize that based on what is the optimum setting. If you totally blank, you don't have any data, and if you want to understand what is the impact of the main effects and how they are going to interact with each other, then design of experiment will be the best tool, right? Where we are going to identify what are the levels, low levels and high levels of the each of the factors and how they are going to interact with our response as well as other factors that we are going to see in detail. Okay, is it clear about the optimization?
yes.
Great. Thank you. Thank you so much.
So one time you can open the DOE, sir. The four things just to.
Uh, yeah, design of experiment, I will explain it very detailed. So we have that third element, which is design of experiment. Okay, so I will go in more detail of it. Is that fine, Saravanan?
Okay, sir. Fine, sir.
Okay, yeah. This is just an introduction, right? What are the tools we can use? And also I'm going to take an example so it will give in better clarity. Okay, thank you.
What I trying to say means you show summary, no, sir. In that Taguchi is there on that only. Sometimes Taguchi DOE.
Yeah, we will see that here into the main types of DOE. So there
Okay,
we
okay,
are
sir.
going to see the robust design, right? So we will see that here, right?
Right, sir. Right, sir.
Yeah, just give me some more time. I will also explain that as well. Thank you, Sarvana. Okay, so this is about the optimization, and I'm also show you practically for one of our project how we are going to develop this implementation plan, validation plan, and optimization everything, right? So in some time. This is just an overview first. Let's understand theory first, and then we will go into the practical aspects of it. Okay, so the second part is the implementation. What this implementation consists of, right? So implement the optimized countermeasure or solution with systematic approach. Now you can see there I use the two words here, countermeasure and solution. Both are nothing but the same, right? They are just we can say the countermeasure is more of a Lean Six Sigma terminology, whereas solution is like the general word that we are going to use, right? So meaning of both is same. So don't confuse about what is a countermeasure and what is a solution. They are the same. Okay, so in implementation, we also need to follow some of the important steps here. The first thing, we must have the clarity about what we are going to implement, right? So for that purpose, we need to create implementation plan. The first step in implementation is we need to create the implementation plan. As you know, in our model project, we identified three important countermeasures, right? So I'm going to show you in some time what are the how we are created the implementation plan for it, and how we are going to create the validation plan. And after that, I'm also going to explain the next steps about it. Okay, so the create implementation plan includes what we are going to execute. So what is the solution, who is going to execute it, how we are going to execute it. That means what are the resources are required, and whether we are having some specific schedule and all that, when we are going to execute, and where we are going to execute, right? So that talks about the area of implementation. So this plan we need to prepare. Once this plan is prepared, then we need to go for the second step, which is communication. We need to communicate that to all the critical stakeholders like process team, management, and stakeholders, right? So this is about, we can say, one of the important document that is used as a management of change, right? So if you are going to execute anything new, this is a must document you need to follow, irrespective of whatever the systems that we are going to use. Yes, Raj, you have some question?
Are we going to revisit the project charter in the implementation plan?
It's depend on the situation, right? So as I said, if there is some major change that is going to happen, right? So we are going to visit the project charter as well. So as I already explained, the project charter is a live document. So if something you found that is not covered into the project charter, of course, we need to revisit it and we need to update it. Typically, the
Okay.
project charter is getting updated at after every end of the phase. Like we just implemented or we completed the analyze phase. So it's a good time to review the project charter. And if any modification or any update needs to be done based on whatever the changes or whatever the implementation that is happening to the analyze phase, we need to do that. And only after that, we are going to enter into the improve phase.
Okay. Sounds good.
Okay,
Thanks.
great. Thank you, Raj. That's a great question. So we need to create the management of change, right? So that includes the all critical stakeholders, including process team, management, stakeholders. But this is just an we created the communication plan as well, right? So we are not going for the execution. Before execution, what we need to do, we need to take an approval from the leadership team, from the management team, right? So this is the change that we are going to make, and what are the benefits of it. At the same time, we also need to consider what are the consequences of it. What is the risk that can be associated with that? So we must be ready for it as well, right? So that is the part that we need to create while we are going to create this document. Once we take the approval, then we need to implement the countermeasure only into the smaller area, right? It's not the mass implementation we are going to make, right? Because we don't know what is the other sides of it, right? What are the consequences or what are the maybe risk associated with the implementation. So we already done the risk assessment many times. Some of it can be happen like we miss one of the topics, one of the point, and because of that, something might happen, right? So there might be some chances of it. So to avoid that, what we are going to do, we are going to implement the solution into the only smaller area, right? And before to go for the mass implementation, we need to validate it. So for that purpose, we need to create the validation plan, how we are going to validate it, right? And then we are going to implement that entire solution, the solution into the entire area, right? So the what is the step that is included into the implementation plan? The first implementation activities. First, create implementation plan. Second, create a document that is called as a management of change, which includes why we are going to implement that solution and what are the consequences of it. Third, we will take approval. After that, we will implement that solution into the smaller area, and then we will create the validation plan. Yes, Sarvanan.
Yes, sir, you're right, sir. In my project also, what we'll do means
Mm-hmm.
told first lab we have optimized the solution for implementation. We will do lab
Mm-hmm.
test, then field testing for 5 tractors. Then we'll choose
Mm-hmm.
TFR. TFR means test for reliability. For
Right.
50 tractors, we'll put and see in the field how it's performed
Mm-hmm.
in different application, different region, and with the
Mm-hmm.
customers location. Based on the
Yeah.
results, the pilot lot will implement for 5,000 tractors. Then it will come in the
Mm-hmm.
production, sir. It is as a PMO big project also. This is a
Absolutely.
step towards.
Great, great, Saravanan. Thank you so much for sharing the practical insights. And as we already seen, like one of the project that is already shared by Saravanan into our community, like what is the importance of following this approach and creating the implementation and validation plan. Thank you, Saravanan. Great. So once we implement the solution into the smaller area, right? So I'm not talking about the big area, right? Because once we implement the solution, even it is a small area, we need to validate it first, and then we need to go for the mass implementation. Okay. So how to validate it? Let's understand what are the tools and techniques that we are going to use as a part of this validation. And once we learn that, we will go to our model project. There, I will explain three important significant factors that we identified. We implemented it, and after that, we collected the data, right? So whether they are effective or not, that we are going to test by using various tools. So I will also explain what are the tools we can use. Let's understand some of them here. We can use the hypothesis testing. That is one of the great tool that we are going to use at every stage of our project to check whether there is any significant improvement, right? So what is the before and after scenario? Is there any significant change or not? To check that, we are going to use hypothesis testing. Second tool that we can use is the graphical tools, right? So that also includes the lot of tools as we already seen into the optimization as well. The third thing is the before and after control chart. So we can have the before and after both control chart into the same window so that we can see what was the before scenario and after implementation, what is the change, right? So that we can see at a glance. Fourth, we can use the before and after measurement system capability. Now, this is only if our countermeasure is related to the measurement system analysis. So we can say in measurement system analysis, if we found some issues, if your measurement system is not capable and you take some countermeasure and after that you want to test whether it's a real improvement into the MSA or not, then we can say before and after MSA also we need to conduct. Depending on whatever the product, service or information that you are going to produce or you are going to supply to your customer, we can also use the test that is associated with your project. That can be the tensile test, reliability test, durability test, or any other test, right? Or we can also see that there is the welding test. Whatever the test that you are going to conduct on your part or into your services, that you need to do before and after, right? And by using hypothesis testing, we can check whether there is a significant improvement into that particular parameters or not, right? And the last tool that we can use is the before and after capability study. So there is an improvement into the capability of the process by which you are going to create the parts, right? So these are the tools we can use, and by using those tools, we can validate whether there is a significant improvement or not. Is it clear?
Yes.
Yes.
Great. Now, as we had already seen a lot of concepts here, right? And it might be confusing if I will take the DOI along with it because it's a lot of content, right? So before that, what I will do, before shifting to the design of experiment or to start the design of experiment, let's see what is the implementation plan, validation plan, and how we can validate the before and after things, right? Is that fine?
Yes.
Okay, great. Then we will come back to learn the design of experiment and we will go in more detail. We will understood what are the four important segments into it. And we will take another example, practical example for the DOE, and then we'll summarize the session. Okay? Yeah, might be you can see it now.
Yes.
Yes.
Yeah. Okay, great. So you can see here, these are the three countermeasures that we have planned into our project. The first one you can see that is coming from the auto pressure control systems, right? So that is like Pokayoke fixture for component orientation, right? Then the second countermeasure we defined is the auto cutoff sensor for the pressure setting. And the third one, visual gauge indicators for the machine panel, right? So I just summarize here. Like these are the three countermeasures we defined: auto pressure control system, Pokayoke jig for assembly orientation, and third one is a digital work instruction, that is ESO base. During the last session, we also discussed like when we are going to plan the countermeasure. Ideally, plan the countermeasure at the level 4 and above, right? So level 4 talks about the Pokayoke, level 5 talks about the automation, and level 6 talks about the design change so that we can eliminate the root cause of the problem completely. So you can see here into our project, we defined three countermeasure. Out of that, two are at the level 5 and one is at the level 4, right? So what is the importance of this? Once you are going to execute or once you are going to complete our project, the results of our project will be sustainable. Why? Because our countermeasure are at the strongest levels. Now, let's talk about the first countermeasure, auto pressure control system. So we are going to automate to eliminate human error, right? So this is the level 5. And in that, what is the implementation plan? You can see install sensor-based automatic pressure control, disable manual adjustment options, calibrate sensors and test thresholds, train operators on the new systems, and after that, update the SOPs and PM checklist so that we are ready for the implementation. Once we implement, then we need to have the validation plan. Like we can use the control charts to check whether the pressure readings are consistent or not, run test batch and compare defect percentage, whether there is an improvement or not. Ideally, we can say we are going to check whether there is a 90% or more improvement into the defect reduction or not, right? Because we are going to invest some of the money here and significant resources are going to be invested. So we must get the significant results like around 90% of improvement or something like that. And after that, conduct the Gemba walk and review the daily pressure loss. So how the uh, this injection pressure is getting monitored, right? So whether there is any variation or not, so we can test that. So this is the way of creating the implementation plan and validation plan for the countermeasure that we are going to execute, right? We can take one more example and then I will go to the data and I will show you that how we can use the different tools, thereby we can validate our implementation. The second example here is the Pokayoke jig for assembly orientation. This is a level 4. Make it hard to do wrong. Like in that, we're not directly go for the development of the jig. Firstly, what we'll do, we will design the jig with the shape and slot restrictions. Then we procure or 3D print the jig for the pilot test, right? So we will have just 3D print or some low cost model. Thereby, we are going to check whether that is effective or not. We will provide operator training to use the jig at station, observe usage and collect the defect data, whether there is an improvement or not. Once it is there, there is improvement after validation, right? So it also consists the implementation validation together. If it is validated, right, and we can say the solution is effective, then we can finalize the standard jig and roll out to all lines. So it's a mass implementation. I mean, validation, what we are going to do, conduct before and after defect comparison, track operators compliance for 1 week, conduct 100% visual inspection for some time, like a week or two, something like that, and set the acceptance criteria. Like by implementation of this, we should have the less than 2% of error rate, right? So this is another example. By thereby we can have the implementation plan and validation plan. Is it clear? Great. So we can see here there is the we have the data for before and after for the pressure defects, right? So what is the impact of pressure injection control that we inserted, right? So that's our first countermeasure. Second countermeasure is related to JIC implementation, and third countermeasure is related to ESOP implementation. So for each of these countermeasure, we have the before and after data, right? And we are going to see that whether these three countermeasures are effective or not by using various tools. Is it clear to you? Are you with me till the point?
Yes.
Okay, great. So let's talk about the first countermeasure, right? So which is the pressure defects before and after. Now, as we are going to use the control chart here, as I explained to you, we are going to see before and after into the same control chart so that we can see what is the impact of implementation of that countermeasure, right? So I just summarize this data here, right? You can see it's the same data. In that, the first 30 readings will be for before, and after 30 readings will be for the after. Can you see this data?
Yes.
Okay, great. So what we will do, let's go to the start. We'll go to the control charts. We will use the control chart for individuals, and we will use the individuals. Why we are going to use the individual chart here? Because we just want to see what is the impact on the values of the defect percentage as we are going to implement the solution, right? So we can insert here as the pressure defects before and after data, right? The first readings for the before and after readings will be for the after implementation, right? So we can click on eye chart options, go to the stages, and here we can add define stages with this variable, right? As we are having the our data, I can see the numbers into the column C1, so which is a run, right? So we are going to just click on the run. So all the observations, right? So all the defect percentage that will be getting plotted on the control chart into the single control chart. And if there is some change, so automatically control limits also going to be changed, right? So we'll click on these limits, estimate parameters, display. Yeah, we can click on this display, and we don't want split, right? We just want entire data of before and after into the one control chart, right? So that's why we are going to click on do not split and click on OK. So once you click on OK, you will get the control chart that will explain what was the before situation and after implementation, what is after situation, right? Can you see here clearly? Like the before scenario, after implementation of before implementation of the solution, the average defect percentage was 6.22, and after implementation that is increased, that is reduced to 1.13, right? Even if you can see the control limits are from 0.61 to 2.87, and here is for 2.14 to 10.29, right? We can see there is a significant improvement into the control chart. From this, we can say there is a significant improvement into the defect percentage after we implement the first countermeasure regarding the pressure sensor automation. Is it clear?
Yes. And I do have a question.
Yeah.
So if you look at that the chart on the left, the before, the mean value is 6.22, right?
Right.
So based on your experience and uh, if after implementing that, the mean value is not changed, but the population is close to mean value. Is that kind of occurrence did you see in your experience?
I didn't get your question. That means you're saying that the mean is same, but the variation has reduced.
Right,
Like that?
right. I mean, not yeah. The
Yeah.
population, the dots are very close to the mean.
Right. So that means
You see the
you're,
after. Sorry to cut you.
yeah.
So if you look at the after chart,
Mhm.
the population is very close to the mean.
Yeah. So this is because you can see here there is the two things. One is the mean is high, 6.22, as well as the standard deviation is also very high, right? So let me complete or let me use the another test on this so that we can also compare the standard deviation. Though it's a very obvious from the control chart we can see here, the standard deviation is very high into the first case. And after the standard deviation has also got reduced, right? So it's not only mean that is getting reduced, the standard deviation value is also getting reduced. That means the process is more stable. I can say it's having the low variation compared to the process that is before implementation of the countermeasure.
Right, I agree with you. And
Yeah.
can you share us with any real time project which so far whatever in your experience, like you know, you're telling like some examples, right?
Mhm.
Uh, the leakage or missing parts. So like
Mhm.
that, in your experience, did you see such a big improvement of any projects what you have done?
Obviously, any project that we are going to execute, so in each of the projects, we are going to implement some countermeasures, right? So if it is a continuous data, obviously we can use the control chart in that case, and we can show like what was the before and after scenario, right? So every time we are going to execute the solution, you can see this example in all the projects, right? So similarly, now
Mhm.
what is the project that we are taken into this entire hackathon process is the defect reduction project, right? So this is like a
Okay.
live project, right? So we collected the data before and after scenario and we check what is the improvement, right? In
Okay.
same way, we can also deploy it for your project as well. We also seen some of the
Okay.
practical examples like the Saravanan has shown, like what was the complaints earlier and after implementation, what is the chart for the complaint, right? So in that also we seen this individual chart and in that we seen what is the improvement that is happening. Okay.
All right.
Great. Now, if you want to see that from statistical perspective as well, like what is the standard deviation improvement and all that, we can use the another test. Let me go to the data, right? So this is the original data we have. We can use the another tool here, like we can use the two sample t-test. And instead of this, I've taken that for the another example, but let me remove that. If you have the data in both samples are in one column, we can also select that option. Or we can select each sample is in its own column, right? We already have the before and after data in two separate columns. So we can select before and after, right? And we can click on box plot, click. Can you see that, right? So we can also see the
Yes, I can.
spread, right? Spread. That's a interquartile range you can see for the before that is bigger compared to the what is the after, right? So we can also see that the variation is also getting significantly reduced,
It's
right?
7.36.
We can also add here as the data labels, we can add the means y value. We can see. So before it was 6.21. Let me make it bigger. And after that is 1.12. Now let's take another example, right? So we understood the first countermeasure by using the control chart. Yes, there is a significant improvement. Now let's talk about the second one, right? And let's use the another tool that I already used here. We can use the hypothesis testing here to check whether there is a before any improvement after, right? So what we'll do, thus there are two samples and we want to study whether there is a significant improvement into the mean or not, right? So we can go to the stat. We can go for the basic statistics. We can use the two sample t-test. Here, as we conducted that for the first element, we can change it to the jig defects before and jig defects after, right? We can click on options here. Whatever the decision that we are going to make, that is with a 95% confidence level, right? That's the standard into the hypothesis testing. If you want to increase that, we can also increase that up to the 99. Or if you want to reduce, we can also reduce that up to the 90 percentage. So depending on the criticality of the process and criticality of the solution, we can change the value of the confidence level. But generally, 95% is the default value that will be available. Now here in this situation, we want to check, right? So we can also have the one-sided hypothesis, or we can also have the two-sided hypothesis. Now, at this point of time, we just keep the default setting as it is, because our interest is to understand what is the impact of the impact of the countermeasure, right? So we'll not change this. Click on OK. We need the box plot, because in box plot we can have the clear picture, like what was the before and after scenario. Click on OK and OK. So after that, we will have the clear picture about the defect percentage. So we can see before implementation of the jig, the percentage was 5.01, and after implementation it was 0.79. So can you see that there is a significant improvement into the your defect percentage after implementation of the jig fixture for your orientation? Is it clear?
What is that stars is like something.
Yeah, star is an outlier. So we can say that's an unusual observation that is getting noticed into your data collection, right? So that might be the typo error, might be the something that has happened at that point of time into your process, and because of that, these outliers are present.
Okay, we need to go and revisit that.
Yeah, you need to go into the detail. You need to understand why these are the outliers. We need to investigate that, and after that, if you
And
want, you can
if
remove
if
them and you
if,
can
if you
take the
click
action.
if you click on a
Yeah.
star, it's going to give you which number and all the information.
Yes, yes. So we can click on brush and you can select these 2 points, right? It will give you, this is a point number 17 and 24. Can you see that?
Oh, okay, okay.
All right. So these are the 2 points, 17 and 24. And let me visit the after data and we can go to the, you can see that is also getting highlighted with a dot. Can you see that dot
Okay.
for
Yeah,
a
I
bit
got it.
before and also 24, right? So you can see all the values. You can see this is a 0.6 below 1 and suddenly you will got 1.74, you got 2.03, right? So these are the some unusual observations or something other than the jig that is getting contributed, and because of that some issue is there, right? And that's why these are the two outliers present. It's clear?
Yes, thank you.
Okay, great. Let's talk about the third countermeasure, right? So we implemented the first countermeasure and we seen with the help of control chart whether there is a significant improvement by looking at the before and after control chart into the same graph. Into this for second countermeasure, you use the hypothesis testing. We use the two sample t-test as we have the true samples, and we are going to compare the mean and standard deviation. So we've seen that there is a significant improvement. Now there is a third countermeasure, right? Now, can we use the same tool across or the validation of this all three countermeasures? Absolutely, right? We can use any one of the tools for the which can be meet the intent of it for the validation. But just to give you and I can say the to explore the more options, I'm just giving you the one tool for the validation for the pressure, other tool for the validation for the jig, and now let's learn about the third tool which we can use for the validation, right? So we can also use the before and after control chart here. We can also use the hypothesis testing here. But as we already learned that for the two previous two countermeasures, let's learn the third tool here. Is that fine?
Yes.
Okay. So we will go to the now graphical tools. We will select the histogram with fit, right? And now just have the data for both ESOP defects before and ESOP defects after. Now, what is the important thing here? We want on the same graph, right? So that we can compare them. If it is on the separate graph, we can also have that option, but it's very difficult to compare, right? If in the separate panels of the graph, we can also see that there are two graphs, but there are this into the separate panels may be tricky to interpret the results. So what we can do, we can click on this, overlay on the same graph, right? So we can have the before and after data into the same histogram, right? And then we can click on OK. Okay. It's very clear, right? The before data is indicated by the blue color, right? Now we can see some of the data is overlapped here. We can see there's a second column, right? It's overlapping. Is the below one is for the before and upper one is for the after, right? That we can clearly see here. If you look at here, what is your interpretation from this?
Can't we separate them the way like what you did in the box plot?
Yeah, we can separate
Like
them. As I already mentioned, we can use the different tools. We can use the box plot. We can use the
no.
hypothesis testing. We can.
I'm asking in the histogram before and after.
Mhm.
Can we put it in the two side by side, not overlapping?
See, this is the some data is overlapping, right?
Oh, okay.
Right?
Yeah, makes sense.
It's not the
Yep.
individual points, right? It's the bins are getting plotted into the histogram. It's a different tool, right?
Okay.
Right? So that's why you can see this is the before one. So we can clearly see by the, just look at these normal fit curve. Can you see that? Just don't look at the bars. Okay, don't look at the
Okay.
bar. Just look at this curve. So can you see that
Yeah,
what was the before percentage and what was the after percentage?
right.
Right?
It's 10%.
So
Yeah, the frequency.
yeah, right. So we can
Okay.
see here clearly, here as a summary as well, you can see the mean before was 3.9 percentage and after it is 1.12. So there is a significant improvement. We can clearly see. Standard deviation before was 1.02, later it is a 0.3, right? So there is the huge improvement into the, I can say the after implementation of the ESOP, right? So thereby we are going to validate our countermeasure, right? If you want to use the another tool for it, like you said, I want to use the box plot for it. Okay, just go for it. Click on graph, go to the box plot. We can have the with groups. We can have the, click on that. We can have the ESOV and click on OK. I think I need to select the another option. We need to go to the box plot. We can have this ESOP before and after. I just want this. Click on this, add data labels. We can add means. Okay, if you want them separated like this, you can see. Before it was 3.9, after it is 1.1. Can you see that?
Yes.
Yeah. Now you can see in the data, all the three countermeasures we can see there's the before and after percentage is varying, right? Because in the first you can see it is 6.2, second it is the maybe 5.01 and third it is coming as 3.9, right? So before. So might be the case like we executed the first countermeasure, some improvement that we are going to see, and after that we are going for the second, and after that we are going for the third, right? So before data is totally depending on when we collected data for that particular uh, scenario, right? Like before and after. Is it clear?
Yes.
Okay.
Yes.
Okay. So what we can let me stop the sharing now. So what we have learned so far, right? So we understood when we go for the implementation, it's like we need to create the implementation plan, right? We need to implement that at the smaller area after the optimization of the solution. And then we also need to validate it before implementation into the entire area or for the before the mass implementation, right? So that was the first part we had seen. Now let's go to the design of experiment. Can you see my screen?
Yes, I can.
Yeah, I think there is the issue only with the Excel because maybe the data is huge and that's why it is not processing. Okay, so let's talk about the design of experiment. Now, when we go for the design of experiment learning, there are a lot of things we need to understand because it consists of a lot of terms into it. Into the training, when you are going to learn from the our learning management system, you will get to know that there are too many concepts are there like factor, levels, the saturation experiment, degree of freedom, right? Then the resolution 3, 4, 5 designs and all that. So we have covered that training before to start the design of experiment, right? So there is the big training on that. In some time, I will also show you the presentation slides in that how you will learn the design of experiment during our during your training into the from the learning management system, right? Now, before that, just understand here when we go for the learning of the design of experiment, there are four important phases. The first phase is about the planning, right? So in that, a lot of things are involved. Like we need to plan the resources and experiments to get the most information, right? So let's talk about what those information like. Before to start the design of experiment, we need to mention what is a problem, right? That problem is, we can say it's a practical problem, we can see as it is. Then we need to convert that problem into the statistical problem, statistical statement, and that will be our goal. Then we need to develop an experimental plan based on the subject matter expertise. And after that, we need to ensure process and measurement systems are in control, right? So that everything is covered as a part of planning. So I will not go in more detail of it here. Just I'm explaining overview of it. There is a detailed training on the design of experiment that you can go through the learning management system so that you will have the better clarity on it. So the first phase is the planning. Then we have the screening. Why screening is important? Because it is depending on the number of factors. If you have the more factors, let's say if you are having the more than 15 number of factors, the planning of design of experiment or executing it, so it's really hard. And I can say at the same time, it is not effective. So by using the various tools, like we can use the brainstorming, theory of elimination, right? So we are going to use the various of techniques, and thereby we are going to reduce the number of factors uh, less than 15, and then we are going to take the actions on it, right? Then the third phase will be the optimization, and fourth will be the validation. So I will explain all these steps when I'm going to explain you the model project, right? So I have also created the design of experiment for our model project, and I will also explain what are the steps that we need to follow during the execution of the DOE. Is it clear? What are the phases in DOE? Just remember the names. Once you go through the training, you will get a better clarity about it. The first phase is planning, second is screening, third one is optimization, and fourth is validation. It's clear?
Yes, it is.
Great. Thank you. Okay, so once we know what are the phases, once we know all the basics and everything about it, then we need to go for the design of experiment. So there is some preparation that we need to do before we go for the design of experiment. The first one is provide training to each and every person who is getting involved into the design of experiment. Why it is important? Because everyone who is a part of design of experiment is very critical. They must understood what is the importance of randomization, why we need to collect the data more accurately, right? And why it is important to be there for the data collection all the time, right? Because that is going to influence entire output and your analysis. So that's why provide training. Second, validate the measurement system. So whatever the measurement system that we are going to use into the design of experiment, that must be capable. Third, check for all combinations of factors. So sometimes we design the low level and high level for the factors. What is low level and high level? Don't worry about it. Once we enter into the training, you will get a clarity about it. But just understand here, to optimize all the factors that are getting involved into the design of experiment. For each of the factors, we have the low value and high value. And sometimes we are also going to add the center points. Though adding of the center point is strongly recommended. And I will also say that you must add it the center points as well. And thereby we are going to design the data collection format. Now during this combination of factors, sometimes we get such a combinations which are not practically possible. We cannot set that factor settings into the real life. So we need to understood those settings with the communication or with discussion of the subject matter expertise, whether these combinations are possible. If you feel any combination is not possible, we can remove that or we can change the factor settings into the design of experiment. And the fourth part will be perform trial runs, right? About which you have some trial, about which you have some doubt. So thereby everyone will get and clarity like how the design of experiment, how to collect the data for it, right? And so once you perform the trial runs, then to go for the data collection of the real design of experiment. Is it clear? This is about the preparation for design of experiment. Yeah, I can understand that there is too much of topic we've seen today, right? But that everything come as a part of the implementation and validation. Is it clear?
Yes, Vijay.
Great, thank you. Now, to perform the design of experiment, we can say that we are going to use the simulation model, right? So we are going to collect the data together for this into the training you can see. In that, we are going to plan, create, and conduct an experiment. Once we collected the data for it, then we are going for the analyze and interpret. I will show you this for the model project in some time, right? How we can analyze and interpret for the data that we are going to collect. Okay, so this is general procedure. There are two important steps into it. And the last part is there are three important types of design of experiment. The first one is the full factorial experiment. That means in that we are going to consider all factors along with their the levels which are considered into the design of experiment. If your number of factors are more, then instead of full factorial, we are going for the fractional factorial experiments, right? That means we're just going to consider some part of runs out of all the runs that is possible. And the third one is the robust design. As a Saravanan asked some time before, if you want to work on the design part to make our product design, process design, or service design very strong, then for that purpose, we need to focus on mean and standard deviation both, right? And in that case, we are going to use the Taguchi design, right? So that also you will learn into the training. So these are the important parts related to design of experiment. This is in addition to the terms and concepts that we are going to learn into it. Is it clear? Just an overview of the design of experiment.
Yes.
Great. Now let's summarize. As a part of the challenge now, challenge 9, what are the activities that you need to complete? If you are going to join the challenge as a green belt, you need to go for the completion of the chapter 17, right? So just visit the chapter 17 into our learning management system, understood what are the all concepts and everything and how we are going to execute it, and to complete the assessment number 5 from the learning management system, which also consists of two types of assessment, multiple choice questions and the situational questions. Situational questions will help you to understand or help you to prepare for the real life problems. So situational questions are designed in such a way that what is the course of action that you will take once you see that particular problem into the real life, right? So these two assessments will help you to prepare for your examination, for your understanding of the Lean Six Sigma, as well as for the real life problems. I will explain the chapter 17 presentation slides in some time. Then there will be the black belt. If you join this program as a black belt, of course, chapter 70 you need to complete. Along with that, you need to learn advanced DOE, which talks about the fractional factorial design of experiment and one factor experiment. So this is the advanced DOE that you can learn. And you can also learn the advanced lean tools. Maybe I will explain that into the next session. And the assessment number 9 you need to complete as a part of black belt. I just highlighted it because that is also the same exercise into the last session. So there is no new assessment. If you already completed the assessment 9, so you need not to complete any assessment as a black belt except this assessment 5. After the end of the session, so you will go through the recordings and you will also see what are the tasks that you need to complete as a part of the challenge 9 below that video. Then we need to identify the countermeasure for your project and we need to optimize it by using the optimization tools that we just learned. We need to implement the countermeasure, and after that we need to validate it by using various tools and techniques. And the last but not the least, schedule a call with me, at least 10 or 15 minutes, discuss what is your progress. If you need any help in understanding of the concepts in practical execution of the project or anything that is holding you back, let me know what is your progress. And if you need any help, we can work together on that. If you want to share anything into the our live call, right? So I will just let me know one day before so that I can create a slot for you, and you can show your presentations into our this weekly live call. So this is also going to help you to improve your presentation skills, at the same time give you confidence to solve the problems as well. Is it clear? What are the tasks we need to complete?
Yes, sir. It's clear.
Okay.
If you permit for 5 minutes time, can I show that what I shown the presentation with a team? Excel sharp failure. Just 5 minutes.
Okay, sure. So let me. Okay, so before that, I need to stop the live streaming as well. Okay, so it's already time. So let me stop the live streaming first. So thank you so much for everyone who is watching us live. Okay, so I really appreciate your patience, your time, and I hope you got a clarity about how this Lean Six Sigma Challenge 9 is going to be work.